Hi everyone, and welcome to our video on a word problem involving a natural log. So it says the demand for a new toy can be modeled by P of x equals 20 minus 6 ln of x, where P of x is the price consumers will pay in dollars and x is the number of toys sold in millions. Find the revenue function. Okay, so a little bit of recall back here. So remember that revenue. Let's put it right underneath. Revenue is equal to price times quantity. And I always just think of like a shirt as an example. So if a shirt is $5 and I want to buy 10, I know that would be 5 times 10, so I'd be paying $50. Okay, so but in these problems, they usually give you some weird function as price. So here they do say this is price. P of x is, they said it's price, is this whole thing. So let's rewrite it. So let's rewrite it using r of x equals, and then they told us the price up there, parentheses 20 minus 6 ln of x, and then times the quantity. Well, they also are telling us the quantity. X is the quantity because it's the number of toys sold. So usually that's how it always is. Now let me do a dot instead. There we go. So price times quantity. Quantity is just x. Okay, so there's our setup. Okay, and then we can distribute the x. It might be better to do that. It might not. Maybe there's no difference. So I'm going to go ahead and distribute the x. So let's times each of these. 20x minus 6x ln of x. Okay, so the ln of x is its own function. So don't take that x there and that x and make it x squared. That wouldn't be the same thing. So ln of whatever usually likes to be left alone, and it might be best to put the x or whatever in parentheses. So it's ln of x is staying as ln of x. Okay, so that if we did multiply it like this, then this is how it would look. So again, it might have been better not to, so we don't make the mistake of doing x squared over there. But it's also nice to see how it would have worked. And I'm going to leave it like this. And I'm boxing it. Okay, so that is the revenue function. And then it says find the marginal revenue. Remember, anytime you see marginal, it's really just saying do a derivative. So we need the derivative of this r of x. Okay, so I'm going to rewrite the r of x. So we have 20x minus 6x ln of x. And then let's do our derivative. Okay, so we've got, let's see, I'm going to do it in blue. So r prime of x. Well, the first term is just a linear part, so that means it's just 20. The second part, though, okay, so I've got the minus 6 is hanging out. This is a product, so that means we need to do the product rule. Okay, so we've got, let's do some colors. So I'm going to do that in green. So that's our U. And let's do this in purple. That's our V. And remember, the product rule is telling you, so use a bracket because the negative 6 is just waiting. U prime V plus UV prime. And that's a V. And then we'll plug those in. All right, so we've got still r prime of x, still 20 minus 6 bracket. All right, u prime, well, x is u, so the derivative of x is 1. And then v is just the natural log of x. There's those. And then we have plus u. Again, u is just x, so plus x, and then the derivative of the natural log function, so ln of x. I mean, you can still think of it like this. You can say, okay, so the x here needs to get put in a denominator, and then the derivative of that, the derivative of x would be 1, is put in the numerator. And then use your bracket. There we go. Okay, so there's the big setup. And then look at the interior of this parenthesis or bracket, and let's simplify. Okay, so I'm going back to black ink because I did my derivative, and now I'm just rewriting. So I have 20 minus 6 bracket. Well, 1 times ln of x will be just ln of x. And then look over there, that x and that x, this x is in a numerator, this x is in a denominator. If it helps, we can put a 1 down there. But either way, the x's cancel, and we're left with just 1. Okay, and then let's distribute the -6 now. So we have r prime of x is equal to 20 minus 6 ln of x minus 6. And then I needed just one more line, but I think it's fine if we write it to the side. So 20 minus 6 is 14. So we can write this as, well, let's put it to the left. R prime of x is 14 minus 6 ln of x. Okay, so that's the answer for number 2. I just needed one more line. Okay, so that's our marginal revenue. So remember, marginal is just anytime you plug something in, or marginal is just making sure you get a derivative. Now we're going to plug something in. So this says find r prime of 4 and interpret. Okay, so r prime of 4, let's plug it in. Okay, so I see it right above. It's 14 minus 6 ln of 4. And then here we'll need a calculator. So r prime of 4 is equal to, okay, so I have Desmos ready. So 14 minus 6, and then you could type in the letters ln and it should know it. It's here in the function menu though. And then 4. I notice they put parentheses for you. That's nice of them. Okay, so 5.68. Okay, so we'll say it's 5.68. So to 2 decimals. Okay, and now let's figure out what they mean by this. Okay, so r prime of 4. Well, let's look back. So they said, so we found the revenue. They said where p of x is the price we'll pay and x is the quantity. Well, I don't see the symbols for price, but I'm assuming they mean dollars. Okay, so let's assume that since they didn't say it. So this is dollars, and then it's a rate because it's a derivative. Per whatever the x unit is, which is looking like toys. X is the number of toys. Okay, so that means, and it's a positive number, so this means revenue is increasing at a rate of $5.68 per. It says, okay, so let's also make sure we're careful with this. So x is in number of toys in millions. Okay, so that would be per 1 million toys, per million toys. When 4 million toys are sold. Okay, so that's its breakdown. Okay, so there's our rate. Okay, so increasing, good sign. All right, and now let's see number 4 here. So it says how many toys should be sold in order to achieve a marginal revenue of $3.25 per million toys. Okay, so this they're saying is the marginal revenue. So they're saying r prime of x is $3.25. Well, we have a marginal revenue function. Let's rewrite it down below. So there's our marginal revenue function, and they're saying change your left side this time. They're saying this is 325, so rewrite that as 325 and have it equal to 14 minus 6 ln of x. And so we need to solve for x here. All right, so to solve for x, we need to get the natural log function by itself first. So our very first step will be to subtract by 14. Okay, so minus 14, and we'll have, okay, so this is negative, I don't know if I can do that in my head. I can make a guess, 1175. Let's double check those. So 325 minus 14, 1075. I was off $1. Okay, so negative 1075 equals negative 6 ln of x. And again, I want the ln of x by itself, and it might help, like we could say, oh, this we need to solve for. And then eventually solve for x. So I'm still thinking, get this by itself. So we should divide by negative 6 here. Okay, so 1075 and 6 divide. The two negatives would cancel, but I mean, I have that ready anyway. So I have the answer, and then divided by negative 6, just to get a positive. Okay, so we've got 1.79 and then 167. Let's keep the decimal pretty long. 1.79. Go back to black ink. 1.79, 167 equals ln of x. Okay, and then to solve for the ln of x, what we do is we use e on both sides. So we need e of whatever this number is and e of ln of x. So we put the e in because the e and the ln kind of cancel. You're left with just x. Okay, so e and ln are inverses of each other, so that's why we're left with just x. And then this other part, we would use a calculator again. So we need to do e, and then I have the answer to the answer. And it looks like we should probably just round to 6. So 5.999, let's just round to 6. Okay, so we've got x is 6. And then let's make this answer official. Okay, so it says how many toys should be sold in order to achieve a marginal revenue of $3.25 per million toys. It's saying 6, again, that's in millions. The x is in millions, so 6 million toys. There. Okay, nice. Okay, so let's see what else we got. Okay, so 6 million toys should be sold for that type of marginal revenue. Now this last thing, it says how many units will be sold if the price that consumers are willing to pay is $15. Okay, so how many units will be sold if the price that consumers are willing to pay is $15? Okay, so they're saying the price is $15. All right, and so this doesn't look like we have anything to do with most of what we already found. It's saying go back to your price function. So here's our price function, the p of x. So let's rewrite that. So p of x equals 20 minus 6 ln of x. Okay, so I'm just copying that. Yep. So that's our price function. And they're asking how many units will be sold. So the number of units, they're saying find x in your price function when price is 15. So they're saying, okay, so just change. Let me underline in green. They're just saying change this here into 15 and then solve for your x. Okay, so they might throw something in at the end that doesn't even involve any derivative. That's fine, as long as we're understanding what they want. Okay, so if I have 15 here, let's subtract 20. Okay, so it's very much now like solving the previous problem. Oop, let me change it to blue. So let's minus 20 minus 20. So we'll get negative 5. Let me change my colors again. So negative 5 equals negative 6 ln of x. And then we'll divide each side by negative 6. Negative 6, which is 5/6, equal to ln of x. And then now it's like the last part. So like up here, it's like this step. Once we have ln of x by itself, we'll do the e on both sides. So we'll do e to the 5/6 and e to the ln of x. Now, again, on the right, e and ln of x just reduce to be x. E to the 5/6, let's go back to Desmos. Let's see what we got here. So e to the 5 divided by 6, there it is, written exactly the same way. Again, you might need a calculator, or you might need parentheses, depending on your calculator. But if you're using Desmos, you can make it look the same way. Okay, and we get let's just say 3. 2.3. We'll round to the nearest tenth. Okay, so we've got 2.3. Okay, so let's again just make sure we answer it because there's a word problem. Answer the official way. So it says, how many units will be sold if the price that consumers are willing to pay is $15? 2.3 million. Remember, X is in millions. Okay, so 2.3 million toys. All right, what was toys? They said units here, but the unit involved was toys. Okay, so 2.3 million toys will be sold. Okay, so that's our final answer. Or let's go back to this calculator real quick. Okay, so let me write this whole thing down. So 2.300975. Okay, so let me put that 2.300975. I just want to write all of it just in case again. 975,891. Okay, so that's the full thing, and I'm just putting million. Well, million would mean really times this number by 1 million. Okay, so 1 million has 6 zeros to it. Let's put a dot instead of the cross. And so if I do multiply that by 1 million, back to this. Okay, so the answer times 1, 2, 3, 1, 2, 3. That way we can see, and they might round that up in case they wanted it to the nearest toy. So it will be 2,300,976. So 2,300,976 toys. Okay, because that is now seen as millions. Instead of writing the word million, we can see the full number that's in millions. Just in case. Okay, so there we go. So that's our stuff with logs. Okay, so a little review of some from algebra and remembering how to solve for x inside of a log. Okay, so get the ln by itself first, ln of x, and then use your exponential function. But that's that. Okay, so thank you for watching. If you do have any questions, please let me know.